and welcome to this talk. This talk is about sustainable architectures, and it's about micro apps. And I am Manfred. I am a trainer and consultant, and I'm focusing on Angular. I'm doing a lot of in-house consultancy and trainings in whole Europe, and I'm helping companies with this topic. I'm also part of the Google Developer Expert team, which I'm very proud of. And my current product is also about Angular. It's a product for Angular in the enterprise. So this helps you to make big enterprise scale applications with Angular. It's a workshop. It takes place in-house or as a public one. And I want to start this talk with a picture. Who of you has seen this machine before? Okay, most of you, cool, you are nice people. This is the Commodore C64, the hero of my childhood. And it was already released in 1982. This really shows that I'm growing old nowadays. And it had about 1 megahertz and about 64 kilobytes of RAM, which is not much. And there have been floppy disks that could store 170 kilobytes, which is also not much compared to nowadays capacities. Fun fact, there was even the possibility to save data on an audio tape for the case you can't not afford a floppy disk or a floppy disk drive. Something no one knows is that there already has been a dual-core version of this machine. The dual-core version looked like this. You had to buy 2 examples of them. And of course, the main challenge back then was resources. Resources have been that limited, so that you had to think twice whether to use an integer instead of a tiny integer or a small integer or something like this. So resources was the biggest issue back then. Nowadays, we have other issues. Nowadays, the biggest issue is about complexity, because enterprise systems grow and grow and grow, and so it is really hard to maintain them. After some years, they look like this here. It is just a mesh made up of several technologies. And in addition to that, we have to coordinate different teams. Nowadays, software is written not just by one team, but by several teams, and somehow they have to work together. And then you have to take care about long-time maintainability. Typical business software systems have to be maintained for 10 years or 15 years or sometimes even 20 years. If you look into banks or insurance companies, you even see software that has to be maintained for 50 years or something like this. And then, of course, there is this issue with milk products. Perhaps you have seen it. There are milk products out there lasting longer than some JavaScript framework, which is really an issue. So last time it was at a company training, one guy said to the other one, what you are doing here is that much 2015. So think about it, 2015, it's about 3 years. And this is enough that one guy is finger pointing to you because of your choice of technology. In this session, I want to provide you a remedy for those issues. And this remedy is micro apps. I will show you how to use micro apps in a JavaScript world. And for this, I have also prepared a demonstration. And after this demonstration, I will show you how I wrote this demonstration. And for this, I have prepared some recipes that might be helpful for you. And in the end, as the former speaker said, you have to evaluate. It always depends upon whether something is useful for you or not. It depends upon your current situation. I will evaluate different strategies for building micro apps. But first things first, let's get started with micro apps in a JavaScript environment. So the idea here is quite simple. The idea is not to write a big system that can do anything, because this is something that's really bad for maintainability. It is really hard to maintain something that grows and grows and grows over years and decades. And it is especially difficult when you have several teams involved. because that means that those teams have to talk to each other. Talking to each other. No, I'm just kidding. Talking to each other, communication is vital. But when it comes to this cross-team communications, then you are likely ending up in a situation where you are spending more times with discussions than with coding. And this is what's bad here. And of course, this always involves such political things, political discussions. You know this when you are working for a bigger company. So, as mentioned, it's vital to communicate, but we don't want to end up in communication cycles and the need to communicate everything with all the other teams. Another issue here is that those teams have to agree upon a framework and upon an architecture. And those decisions are hard to change afterwards. But on the other side, when it comes to software that needs to be maintained for long term, you have to be able to change your decisions. No one knows what happens in 7 years. And no one knows if the use case you have to implement in 7 years fits to your current architectural decision, fits to your current technology decision. So being flexible here would be quite nice, wouldn't it? And the remedy for this is to split this big software up into tiny self-contained parts, into tiny pieces of applications. This idea is everything but new. It has been around for about 20 years. For instance, when you've looked into domain-driven design 20 years ago, you exactly found a solution like this. Nowadays, since about, I would say, 3 years, this solution is quite popular because a lot of people have adopted this idea for the backend. They are calling it microservices. And when we take this very idea and when we put it into the front end, we end up with something you could call micro apps or micro front ends. This concept has several names. Several tiny self-contained applications that don't need to know much about the other applications. And of course, as everything, this comes with a lot of advantages but also disadvantages. One advantage here is that every team can deploy everything separately. When you are done, you can just deploy it and your users get it immediately. They get immediately an additional value. You don't have to wait until the other teams have been done. When you are done, just publish it. You can use different technologies. Each micro app can has its own technology and its own architecture, a technology that fits best to your current needs. And you need less coordination. You don't end up with these endless meetings between different teams. And of course, you are ending up with less complexity because you don't have this big software system. You have a tiny one that is doing just one thing. Of course, there are some drawbacks. You have a highly distributed system because sometimes those micro apps and microservices need to communicate with each other. And this means you have to define APIs, you have to use something like REST or like other APIs and message queues and so on. And you are ending up with distributed data because every self-contained application can has its own data store, its own database. And of course, you have to deal with UI composition. For us, for developers, it is a nice thing to have 50 tiny applications instead of one big chunk. But for the user, it isn't. The user is not happy about the need to start 50 applications every morning. This is somehow a grab for him or her. And that means we have to provide everything as a common big thing to the user. And as you might imagine, UI composition is something that affects the UI layer. Everything else can be solved somehow in the backend. There are a lot of solutions for distributed systems and data. So the question now is how to implement something that uses UI composition. And there is one first very simple answer. It is not the last word on this, but the first simple answer is just use hyperlinks. In this case, you had several JavaScript applications, several self-contained single-page applications, and those single-page applications are pointing to each other using hyperlinks, using anchor tags. If you ask me, this is quite a major solution. I mean, hyperlinks have been around for 20 years, and to be honest, I have never ever heard someone to say a bad word about hyperlinks. So this really seems to work. And even though this sounds funny, there are some scenarios where hyperlinks is just the right solution. Just think about a product suite like Google. For instance, there you have Google Maps. And Google Maps is somehow a micro app. It is specialized for one use case. It is specialized into working with maps and routes. And when you want to switch over to another application of the Google Suite, just click this link here, and then you get this menu with hyperlinks leading you to other parts of the Google Suite. By the way, the most important aspect of this whole presentation can also be seen on this slide. If you don't remember anything of this talk, please always remember this fact. This fact is very important for me. I'm putting a lot of emphasis into it. It's about this city here. It's called Steierberg. I'm really proud of it. They have my name in their city name. It's a little city in Germany. I'm from Austria, and since I have seen this, the Germans are my favorite people. So is someone here from Germany? Okay, cool. I love you guys. Thank you. Thank you. It's really great. So let's go on with the boring technical stuff. So as you have seen, using hyperlinks is quite simple, but there is also a drawback, especially in the area of single-page applications. Namely, you are losing state. When you are moving over to another single-page application, your current application is unloaded from the memory, and that means you are losing your current application state. Plus, you have to load a whole new application, a whole new page. And this is exactly what we wanted to prevent when we invented single-page applications. And somehow, you have to make sure that you have a consistent look and feel over all your applications. For instance, that this menu here looks more or less the same in each and every part of your suite. And saying this, I have one idea. Technology that is coming up now quite quickly. It's about web components. You know, web components are these framework-independent components. You write them once, and then you can use them within every product that is built with every technology. And so sharing code has never been as easy as nowadays. So it is really about writing once with one framework or even with vanilla.js and using it everywhere else. And the good message here is that web components are already here because you can polyfill them down to IE11. So that means they work in each and every browser. Of course, it will not be that fast in IE11, but it will work. And all the other browsers are currently adopting this technology. So using hyperlinks is one approach, but sometimes our users deserve something better. Sometimes just jumping between applications back and forth is not enough, and this is where a shell comes in. A shell is just a single-page application that is capable of loading other single-page applications on demand. Single-page applications that have been written with different technologies. And of course, there are several solutions for loading one single-page application into another one. Here I will start with the most ugly solution. What do you think? What is the most ugly solution for this? Iframes, yeah. I don't know about you, but when I hear the word iframe, I'm getting this strange feeling in the stomach. But it turns out that sometimes iframes are quite a nice solution because iframes provide you a nice amount of isolation. Isolation means that the application in the first iframe cannot harm applications in other iframes. A bug here does not influence other iframes. A destroyed CSS layout does not influence the layout of other iframes. Or the application in the first iframe cannot even hack applications in other iframes. This sounds funny, but that's vital when you are including third-party vendor applications. When you are providing something like a plug-in system where other vendors can plug in their software into your shell. So as mentioned, iframes are not the most popular solution here, but sometimes they are just suiting. Another solution for this is to bootstrap several single-page applications. That means you have one index HTML, and in this index HTML you load several bundles for several single-page applications. For instance, an Angular application or an React application or an AngularJS application. In this case, please really consider lazy loading. You probably don't want to load everything at once because of bundle sizes. And when doing so, it would be a good idea to provide a common interface to the shell for all your micro apps. That means that the shell should not know details of micro apps and used frameworks. The shell should only know how to provide events to micro apps and how to consume events from micro apps. So the shell can communicate with all the micro apps and orchestrate them. And here one idea is also to use web components. You could wrap your micro apps into web components. Saying this would not be a typical web component. If you ask me, a typical web component is a reusable widget. Here you have a big application you are wrapping as a web component. But to be honest, nowadays also applications, whole applications are just components. Think about Angular, think about React, think about Vue. In all those frameworks, the whole application is a component that consists of components that in turn also consists of components. And so using this would be more or less natural, and it would provide a common interface to the shell. Besides, web components can be really easily lazy loaded. Lazy loading has never been as easy as nowadays with web components. So enough for theory. Let me show you a demonstration for this. What you see here is a shell application. I've written it with Angular because I'm an Angular guy. And the shell application just provides a menu on the left side. And when you click on the menu, something is loaded into this working area here. Let's click on flights, and now here we see a self-contained Angular application. I'm calling it my blue client, and it is directly loaded into this working area. The nice thing about this is that this blue client has been developed individually, and it was also deployed individually. And after it was deployed, this shell just grabs the newest version and dynamically loads it at runtime. As this thing also works standalone, you can also use it in standalone mode. I think this sample here really shows that your micro app don't need to have any dependencies on other micro apps. They are just self-contained systems. When we click here, I'm getting my red client. It's also written with Angular. We can also make use of routing within our micro apps. And when I'm clicking here, then I'm getting this client here. Of course, being an Angular guy, I don't know this technology at all. But in my point of view, this really shows that you can mix and match different technologies. And this is awesome, if you ask me. You can mix and match technologies, not because you want to, but because you have to when it comes to software that needs to be maintained for 10 years or longer. And micro apps also solve this legacy trap somehow. What I'm having here is an old AngularJS application, and I've just wrapped it as a web component, and I've dynamically loaded it into this shell. So if you have legacy code, creating something like micro apps could be a big chance for you, who is using something like this AngularJS or other legacy code. jQuery, okay, Backbone. Okay, cool. So perhaps using micro apps is one solution for your very issue here. Hi Shmuela. Hi Uri. Okay, cool. So as you have seen here, we can move back and forth between my micro apps, but there is something that's even better than this. We can reuse existing widgets written with other technologies within our micro apps. And this is something you need for integrating your micro apps. Sometimes your micro app has to reuse something from another use case, and this is where this solution comes in. This is also possible because of web components. Okay, nice. So saying this, something I found out when I've discussed a lot with my customers is that it would be a good idea to distinguish between two architectural layers in your micro app systems. One architectural layer is something I'm calling the shell architecture. It is more or less the glue that holds together all your self-contained micro apps. And then you'll need to find a solution for shared widgets. And you should really separate those two layers of architecture, because it is quite likely that you are ending up with different solutions for those two layers. On the shell layer, you could go with something like hyperlinks, with something like iframes, or with something like web components. And on the widget layer, you could also end up with something like web components, but also with something like NPM packages and your own component systems. So please keep this in mind. Please separate those two layers. Otherwise, you will end up in cycles during your architectural discussions. Saying this, I have now prepared some recipes for you. Recipes I've used in my case study when I've implemented this showcase. And the first recipe is about communication. Sometimes your micro apps need to communicate with them other. And for this you need to provide some mechanism. And here I have a good message. This good message is one times about using web components. A web component just behaves like a traditional element within your browser. It just behaves like a table or an input or an image tag. And so it can provide something like properties or attributes, and it also can provide something like events. And using those two mechanisms, those two 20-year-old mechanisms, you can hook up all your applications and you can orchestrate them. That means your shell can somehow pass all the messages to the right single-page applications, to the right micro apps. Saying this, in general, you should avoid the need for communication. Because every time you have something like communication between micro apps, you are coupling them to each other. And coupling is something we want to prevent here, because this all is about self-contained apps. But sometimes it's really convenient and also necessary to talk to other micro apps. And for those situations, you can, for instance, go with this very solution here. I think he likes my talk. Cool. So the second recipe I've brought with me is about routing, or as I call it, meta routing. Because now you have two layers of routing. The first layer is your shell application. The second layer is your micro app. And for this, I'm using routes like this here. Every route gets a prefix, and this prefix tells the shell which micro app to display and which micro app to hide. And then the rest of the route is just denoted for the micro app, so that it knows which Angular route to display, or which React route to display, or which Vue routes to display. Another thing, it's about lazy loading. I've mentioned it before. You will very likely want to don't load everything at once. Instead of this, you will want to load your micro apps just on demand. And Lazy loading has never been as easy as nowadays with web components. Using web components, you could just create a script tag in a dynamic way. A script tag like this. With the script tag, you will point to your bundle containing your micro app. And then you will add an element to your page. The element that is pointing to your micro app, to your web component. Here, I'm just calling it client A. And as you see here, I'm also hooking up attributes, I'm hooking up events for communication as seen before. And of course, then I'm just adding it to my page. One nice thing about this is, it doesn't really matter in which order those two things happens. It would also work if you would switch the orders, if you would just introduce your element and then load your bundle. When you are introducing the element first, the browser will ignore it, and then after loading the bundle, the browser will revive it. It will bring it to life, it will render the component into it. So as you have seen here, it's really easy to lazy load a web component. There is also a tough issue here. I've dealt with this issue a lot in the last 6 or 9 months. It's about bundling. Every one of us thinks that bundling is something that has been solved, but in the area of web components, it hasn't. There are several strategies, and somehow we need to automate those strategies. Think about having different bundles with different micro apps and different web components. The first bundle comes from the first team, the second bundle comes from the second team. Of course, those bundles not only contain custom elements, or let's say web components, they also will contain libraries like Angular, like Bootstrap, like Vue, like React, and so on and so forth. And when you are not lucky, you have exactly the same stuff in the next bundle. And now this might be an issue, but it could also be an advantage. It really depends on your point of view. It is an issue, of course, when it comes to bundle size. Loading the same things twice is something that's really bad in terms of performance. But it is a good thing for isolation. Isolation means that each and every team can decide upon its own technology. And each and every team can decide upon its own update strategy. Perhaps I have something like Angular 4 on the left side and Angular 7 on the right side. They don't need to coordinate, they don't need to talk to each other in order to update to a common new version. This is the advantage here, and this is really in the sense of micro apps and microservices. And if bundle size don't matter, I would go with this solution. Of course, if bundle size is an issue for you because your application needs to be used by web users out there using a slow 3G connection or something like this, this doesn't work at all. In those situations, you can try to compile everything down to JavaScript, more or less. And this is what, for instance, Stencil is doing, a quite nice web component framework. This is also what Angular Ivy will do when it comes out in 2019, hopefully. It compiles your code, your UI code, down to something that is very close to JavaScript, something that can be tree-shaking very easily. Of course, there is no wonder in here, and that's why Ivy and Stencil cannot solve each and every issue. Down-leveling everything to something that is quite close to JavaScript works pretty well for UI-based code, for code that is manipulating your DOM, for code that is writing something into your page. But it doesn't work well for something like your router code, your forms code, your HTTP access code. Of course, your HTTP access code cannot get smaller because of down-leveling UI components to real JavaScript or something like this. That means here there is a lot of potential, but it doesn't solve each and every problem, especially when it comes to technical code and not UI code. There is another strategy for this. When you are using something like Vue or React, you will be quite familiar with it. This strategy is using one bundle, and it shares this bundle among all your applications. That means you are loading Vue one more time into your browser. That means you are loading React one time into your browser, or even Angular or Bootstrap or something else. Okay, I think now he doesn't like it anymore. So in this case, you're going with UMD bundles. And one important thing here is that you have to adjust your build process so that this stuff is not built into your application bundles. And then, of course, your application bundles can use those preloaded libraries, those libraries that live within the global object of your browser. As mentioned, Vue is providing a very easy solution to this, also Angular, also React. And for Angular, there are some community solutions to do something to adjust this build step so that everything is using external libraries. Nice. So far we have seen several approaches for using micro apps and for using web components. We've talked about something like hyperlink integration, we've talked about something like iframes, and we've talked about something like web components. And now, of course, the question is, what shall I go with? Which is the right solution for my current issue? And here the answer is one more time, well, it depends. It really depends upon your current situation. I've discussed this a lot with my customers in the last month, and I saw that those discussions are really difficult. We really often ended up in cycles when doing those discussions, because when we are honest, every one of us wants just to have the advantages of all those approaches. No one wants to have the disadvantages of them. And this is not possible. We have to die one death. We have to go with several disadvantages in any case. And to shorten all those discussions, I came up with a decision tree. A decision tree that helps you to identify a first good architectural candidate. Of course, this decision tree is not the last word on it, but it proved to be in handy. The first question I would ask you here is, do you have a lot of shared state and do you have a lot of navigation between your micro apps? Does the user has to move back and forth quite frequently? And if this is the case, then you should try a shell. If this is not the case, then just go with hyperlinks, because in this case you very likely have several self-contained applications that don't need to know much of each other. If you say, no, this is not the reason here, then not the case here, I have a lot of shared state and the user needs to move back and forth on a regular basis, then the next question is, do you need to integrate legacy applications? Legacy applications like Java server faces or like PHP or like ASP.NET. I think every one of us has done something like this in the past. And when this is the case, or if you need a very strong isolation, then consider iframes. As mentioned before, the big advantage of iframe is that one application in the first iframe cannot harm other applications in other iframes, which is vital for plug-in systems. Saying this is not a good fit for public websites. You will not write the next Amazon using iframes, of course. But it can be a nice and fitting solution for intranet systems. And to be honest, I'm seeing this solution quite often nowadays. Not much people are talking about this because, you know, iframes are not that famous, but you find these solutions a lot behind of firewalls in big companies. If you say, no, I don't have legacy applications, we have just the good new stuff, And if you say, no, I don't need this isolation thingy, then the next question is, do you even need a separate deployment? Do you even need a mix of technologies? And if you say, yes, I need this, because we have to maintain our software system for 10 or 15 years, and no one knows what shows up in 7 years, then try to bootstrap several single-page applications within one index HTML. Saying this, you should consider web components for this to provide a unique interface to your shell. And also saying this, you should consider something like lazy loading. If you don't like web components here, just provide another way for a common interface. The point here is your shell needs a common interface. And if you say, no, this is not the case here, I just need one technology and I don't need a separate deployment, we are just one UI team, then go with a mono repository. Go with one big application that is well structured and that contains everything you need for your current use cases. Of course, now I'm a quite nosy person. Normally the audience is asking the speaker some questions. Now I'm doing it the other way around. I'm asking you a question. Who of you thinks that for his or her solution, hyperlinks would be fitting? Okay, quite little, okay. Who thinks iframes is the best approach? Okay. What do you think about bootstrapping several single-page applications? Okay, some of you, nice. Who has worked with web components? Okay, nice. And what's about the mono repo, one big application that contains everything? Okay. And who did never raise his or her hand? Okay, I've imagined, yeah. Who is afraid of Manfred? You don't need to. Okay, cool. So perhaps you are saying, wow, that was a nice talk. And in this case, please look up my blog. I've written a lot of articles about this, about web components, about micro apps. And perhaps you're saying, hey, this is the worst talk I've ever seen. In this case, check out my blog anyway. Perhaps I'm writing better, who knows? So let's come to the conclusion. We have seen micro apps are about decoupling, not only about decoupling technologies, but also about decoupling projects and teams. It's about to minimize the effort for communicating with each other. It's about to introducing a lot of flexibility. The big advantage here is that you can go with the best technology for your current project. Perhaps nowadays it's Vue, perhaps in some years it's Angular, perhaps in 15 years we are doing everything with WebAssembly, who knows? Doing predictions is quite hard, especially predictions about the future. And as you have seen, web components are a quite well fit for micro apps. They are not the only solution, but as you have seen, they seem to work quite well here. And one thing that is quite vital, you need to evaluate. There is not one general answer to the question, what shall I use? There are several answers. Each answer has its very own advantages and disadvantages. So here you have my coordinates. You also find my slides within my web page. And I just say thanks for coming, have a nice day, and if you want, follow me on Twitter so that we can keep in touch. Thank you.